Here we'll be introducing a few more identities, or exactly we'll be looking at the sum and differences formulas. And we use the sum and difference formula to find the exact value of a trig function using our special angles. And our special angles includes pi over 6, pi over 3, pi over 4, pi over 2, 5 pi over 3, etc. So, our first one that we'll be looking at is a sine of u plus v, where u and v represents our two angles. So the sine of u plus v is equal to sine u times cosine v plus cosine u times sine v. The sine of u minus v be equal to sine u cosine v minus cosine u sine v. For the cosine of a sum, we have cosine u cosine v minus sine u sine v. For the cosine of a difference, we have cosine u cosine v plus the sine of u times the sine of v. For tan of u plus v, we have tan of u plus the tan of v, all over 1 minus tan of u times the tan of v. And for the tan of a difference, that's equal to tan of u minus the tan of v, all over 1 plus tan u tan v. Now let's look at a few examples using all these new identities. Here we're being asked to find the exact value of this expression, the sine of 3 pi over 4 plus 5 pi over 6. And we're also asked to find the sine of 3 pi over 4 plus the sine of 5 pi over 6. First, let's look at finding the sine of 3 pi over 4 plus 5 pi over 6. This is the same thing as our sine of u plus v. We know from our sum and difference formula that the sine of u plus v is equal to the sine of u cosine of v plus cosine of u sine of v. So upon expansion, we get sine of 3 pi over 4 times the cosine of 5 pi over 6 plus the cosine of 3 pi over 4 times the sine of 5 pi over 6. From our unit circle, we can recall that the sine of 3 pi over 4 is the square root of 2 over 2. The cosine of 5 pi over 6 is negative square root of 3 over 2. And the cosine of 3 pi over 4 is negative square root of 2 over 2. And the sine of 5 pi over 6 is equal to 1/2. We multiply these two, we get negative square root of 6 over 4. And these two will give us negative square root of 2 over 4. We combine these two, have the same denominator. We have negative square root of 6 minus the square root of 2 all over 4. So here we have the sine of this giving us this. The sine of 3 pi over 4 would be equal to, once again, the square root of 2 over 2. And the sine of 5 pi over 6 would be equal to 1/2. If we add both of these, we get the square root of 2 plus 1 all over 2. From this, we can see that the sine of 3 pi over 4 plus 5 pi over 6 is completely different from the sine of 3 pi over 4 plus the sine of 5 pi over 6. So we are not distributing the sine over both of these. Here we're being asked to find the exact value of the sine, cosine, and tangent of the angle 7 pi over 12. We know that 7 pi over 12 is the sum of pi over 3 plus pi over 4. So to find the sine of 7 pi over 12, we can simplify that to be the sine of pi over 3 plus pi over 4. Using our sum of sine identity, this becomes the sine of pi over 3 times the cosine of pi over 4 plus the cosine of pi over 3 times the sine of pi over 4. So here the sine of pi over 3 is the square root of 3 over 2, cosine of pi over 4 is the square root of 2 over 2, plus the cosine of pi over 3, which is 1/2. The sine of pi over 4 is the square root of 2 over 2. If we simplify this, we get the square root of 6 over 4 plus the square root of 2 over 4, which gives us a square root of 6 plus the square root of 2 all over 4. If we factor the square root of 2 from the numerator and 4 from the denominator, we get square root of 2 over 4 times the square root of 3 minus 1. Now we can find the sine of 7 pi over 12 and the tangent of 7 pi over 12 also by using the same sum here. The cosine of 7 pi over 12 is equal to the cosine of pi over 3 plus the pi over 4, and the tangent of 7 pi over 12 is equal to the tangent of pi over 3 plus pi over 4. Using our sum identity for cosine, we get 1/2 times the square root of 2 over 2 minus the square root of 3 over 2 times the square root of 2 over 2. This simplifies to give us the square root of 2 over 4 minus the square root of 6 over 4. So, or minus 2, the square root of 2 minus the square root of 6 all over 4. Once again, if we factor the square root of 2 from the top and the 4 from the bottom, we get the square root of 2 over 4 times 1 minus the square root of 3. For tan, our tan identity tells us that this is tan of pi over 3 plus tan of pi over 4 all over 1 minus the tan of pi over 3 times the tan of pi over 4. We know that tan of pi over 3 is sine of pi over 3 over cosine of pi over 3. So this is the square root of 3 over 2 divided by 1/2, which just reduces to the square root of 3. The tan of pi over 4 is the sine of pi over 4 over cosine of pi over 4, which is the square root of 2 over 2 over the square root of 2 over 2, which just gives us 1. So now this is all over 1 minus tan of pi over 3, which is square root of 3, and the tan of pi over 4, which is 1. So this gives us the square root of 3 plus 1 all over 1 minus the square root of 3. If we rationalize the denominator by multiplying by its conjugate, which is 1 plus the square root of 3, both the numerator and denominator, this simplifies to give us negative 2 minus the square root of 3. In this example, we're going to find the exact value of the sine and cosine of the angle negative 105 degrees. Now, negative 105 degrees is not one of our special angles, so we cannot use our unit circle to evaluate this. We do, however, know that negative 105 is the same thing as 30 minus 135, and both of these are special angles, or negative 45 plus negative 60 will also give us negative 105. And once again, both of these are special angles that we can use from our unit circle. We also know that negative 105 is also equal to 45 minus 150 degrees. And these are also special angles from our unit circles. And there are many other options. In this example, we're going to use a combination of 30 and minus 135. So to find the sine of negative 105, we can write that as a difference of 30 and 135. Expanding this using our sum and difference identities, we get a sine of 30 minus 135 is the sine of 30 times the cosine of 135 minus the cosine of 30 times the sine of 135. From our unit circle, we can get the corresponding values for each of these angles. So now we have 1/2 times the negative square root of 2 over 2 minus square root of 3 over 2 times the square root of 2 over 2. And this simplifies to give us negative square root of 2 minus the square root of 6 over 4. Once again, if we factor negative square root of 2 from both of these and 4, we get negative square root of 2 over 4 times 1 plus the square root of 3. To find the cosine of negative 105, we know the cosine of negative 105 is the same thing as the cosine of 30 minus 135. For our difference of cosine, we know it's cosine of 30 times the cosine of 135 plus the sine of 30 times the sine of 135. From our unit circle, we can get the corresponding values for all these angles. So here we have square root of 3 over 2 times negative square root of 2 over 2 plus sine of 30, which is 1/2, times sine of 135, which would be the square root of 2 over 2. If we simplify this, we get negative square root of 6 plus square root of 2 all over 4. If we rearrange this, square root of 2 minus the square root of 6 all over 4. and factor the square root of 2 over 4, we get square root of 2 over 4 times 1 minus the square root of 3. Here we are asked to write the expression as the sine, cosine, or tan of an angle. So we're given 3 different expressions. On the first expression, we have cosine of pi over 7 times the cosine of pi over 5. Since we have cosine and cosine here, we know this is going to be a cosine function. So this will be cosine, and since our sine here is negative, we know for the cosine sum and difference, when it's negative here, it's going to be a sum. And our two angles then would be pi over 7 and pi over 5. So all this simplifies to give us a cosine of pi over 7 plus pi over 5. Since we want this as a single angle, this further simplifies to the cosine of 12 pi over 35. Here, in this one, this will be a tan function. So we know this is going to be the tan. Since it's a subtraction here, we know it will be a subtraction. It's going to be 45 minus 30. So here we have tan of 15 degrees. Here we have sine and cosine. So we know this is a sine function. So this simplifies to give us sine. And for sine and tan, the sign that we have here is a sign in our parentheses. So this will also be plus. And here we have 60 degrees plus 15 degrees. As a single angle, this is the sine of 75 degrees. Here we're going to find the exact value of these two expressions. First, we have cosine of pi over 16 times the cosine of 3 pi over 16 minus the sine of pi over 16 times the sine of 3 pi over 16. So we know that this is a sum of cosines. Since it's cosine, cosine, and this is a minus, and this becomes the cosine of pi over 16 plus 3 pi over 16. Now this simplifies to give us the cosine of 4 pi over 16, or just the cosine of pi over 4. We know that a cosine of pi over 4 is the square root of 2 over 2. So all this simplifies to give us a square root of 2 over 2. In this expression, we have the sine of 120 times the cosine of 60 minus the cosine of 60 times the sine of 120. So here this is sine cosine, so we know this is going to be a sine function. This is minus, so we know it's going to be a subtraction. It's 120 minus 60, which simplifies to give us a sine of 60 degrees. And we know the sine of 60 degrees from our unit circle is the square root of 3 over 2. And here's our answer for the complete simplification of that.